So in this lesson, we're going to talk about some of the properties of a trapezoid and a kite. So before we even begin, let's remind ourselves, what is a trapezoid? You see figures on the left that are trapezoids, and you see figures on the right that are not trapezoids. So what is a trapezoid? Well, a trapezoid is a quadrilateral. And it's a special type of quadrilateral. It has at least one pair of parallel, there we go, parallel sides. So that satisfies the definition for these and not for the two here. And I know you're probably saying, well, what the heck is this thing right here? What is that? Well, what you might remember is way back in a really earlier lesson this year. This thing that looks like the credit card with the little triangle and the circle and the little tail on it, we called that a zoid. And it looks like we've trapped a zoid. Oh, come on, you're laughing too. So let's keep rolling a little bit. There's some other vocabulary that goes on. I'm going to go over here to the right side first. So in a trapezoid, we always have bases. The parallel sides are the bases. And the angles that contain the parallel side, the bases, are called base angles. So are you okay with the fact that I got some base angles at the top? That should be okay. And we have base angles at the bottom as well. So the base angles are the pairs of angles that share one of those parallel sides. And if you look on the right side, we talk about what happens when the diagonals of the trapezoid are congruent. In this case, diagonal DG and diagonal AS are congruent. So the trapezoid is isosceles. And you like that? It's trapezoid DAGs for diagonals. And Geometry Sketchpad is going to lead us to something really fun. Let's go check that out. So what we're going to do is we're going to click a button, watch what happens. I'm going to ask you to say, what do you notice? So first we'll take a look at the consecutive angles. Watch these two angles light up. These are what we call consecutive angles. They're not base angles. But look at how those consecutive angles relate. I know you're saying, oh, you're talking too much. I wasn't paying attention. So let's go back. We'll reset and we'll watch it one more time. Watch those consecutive angles. So consecutive angles are the angles that are not the base angles. It's adjacent angles that are opposite the parallel sides. What did you notice about them? Did you notice that they were supplementary? Oh yeah, they added up to 180 degrees. Pretty neat. Next, I want to talk about a pair of base angles. So watch these base angles over at angles A and D. And tell me something about these base angles. Okay, since the trapezoid's isosceles, what'd you notice about them? You want to watch it one more time? One more time! So it looks like those angles A and D slide over to angles B and C. They don't change size and they lay perfectly on top of each other. So the base angles of an isosceles triangle are congruent. And one last one, check out the legs. So the legs are sides AD and BC. Here's side AD, it goes over to side BC, and it's a perfect fit. So it looks like the legs of an isosceles trapezoid are congruent. So let's summarize that in some conjectures. So the first one, the trapezoid consecutive angles conjecture, is that the consecutive angles between the base of any trapezoid, it doesn't have to be isosceles, any trapezoid are supplementary. Those angles add up to 180. The second one is the isosceles trapezoid conjecture, that if you're given a trapezoid that's isosceles, if you know its diagonals are congruent, then its base angles are also congruent. Awesome sauce. And if the trapezoid is isosceles, then its legs are also congruent. So 3 good conjectures about trapezoids. All right, let's move on a little bit. Now we're going to talk about some kites. And similar to before, on the left, you see kites. On the right, You do not. So what's a kite? Well, if you said that a kite was a quadrilateral, and that's not how you spell quadrilateral, it's quadrilateral, there we go. It's a quadrilateral with two pairs of congruent sides. But where are those sides located? So we're going to finish this up in a second. If you notice, this is a quadrilateral with two pairs of congruent sides, but it's not a kite. This is a kite. So in the one on the right, the sides opposite are congruent. So that's not a kite. So if the congruent sides aren't opposite, we say that they're adjacent sides. Remember that word? Adjacent. We had adjacent angles a long time ago. So we're going to say that a quadrilateral with two pairs of congruent adjacent sides is a kite. Pretty darn cool. So let's go back to our geometer sketch pad for a second. Here we go. Here we go. There we are. And now we want to take a look at some kite properties, a bunch of things to do. So we get to watch for a little bit. First, we're going to, I can't want to go there yet. Hold on, I got to give you some more vocabulary. I forgot about that. There's two sets of angles that go with kites. The angles that are formed by the two congruent pairs of sides are called the vertex angles. And that kind of makes sense because if I draw in this diagonal, I make two isosceles triangles. And in an isosceles triangle, the two congruent sides form the vertex angle. So the vertex angles of the kite are still in the same idea. It's the angles formed by the congruent sides. And the non-vertex angles are the ones that are formed by the non-congruent sides. All right, now we can get back to the sketch. Here we go. Take a look at the non-vertex angles. Do you know which ones are the non-vertex angles? If you said angles B and D, you're correct. What do you think is true about them? Watch and tell me. No way. What do you wonder? What do you notice? Did you notice that the non-vertex angles are congruent? Cool. Now I'm going to draw some diagonals. Let me show you those diagonals real quick. Now, if I take point B and drag it around a little bit, and if I take point A and maybe drag it around a little bit, check out the angles formed by the diagonals. Look at the angles at E. What do you think is true about those angles? If you said that each of these four angles are 90-degree angles, you'd be correct. So that makes the diagonals perpendicular. Remember that word? Oh, we love that word. Speaking of diagonals, watch when I press the diagonal button. Are you ready? Whoa! What does that tell you about those diagonals? Let's watch it one more time. So it looks like diagonal BE spins around and lands right on top of DE. So it's that the diagonal that joins the vertex angles, the non-vertex angles, is bisected by the diagonal joining the vertex angles. Diagonal AC bisects diagonal BD. Pretty cool. And the last one, check out the vertex angles. Remember, the vertex angles are at A and C. Are you ready? This is quick. Here we go. Whoa, okay. Let's reset that. That was too quick for me. I'm going to watch A first. Looks like those angles are the same. And now we want to watch the ones at C. Let me reset one more time. Watch them at C. It looks like it's the same. So the vertex angles are bisected by the diagonal. Cool stuff. Oh, that's a lot of conjectures. Here we go. Let's take them one at a time. So first of all, we said that in a kite, we said that the non-vertex angles of the kite were congruent. That was the first thing we saw. That was when that one angle fell down from the sky and landed on the bottom angle. And the second is that the kite diagonals, conjecture says that the diagonals of a kite are perpendicular. They form a 90-degree angle. Cool. Two more that we had. You might remember that that one diagonal was equal to the other part of it. So the diagonal that connects the vertex angles of a kite is the bisector of the other diagonal. So only one part of the diagonals are congruent. The one that connects the non-vertex angles is bisected. And the last one is the kite angle bisector conjecture. And this told me that the vertex angles of a kite were bisected by a diagonal. Diagonally. You like those movies? Good movies. So those are our 4 big conjectures about the kite. Let's go through them real quick again. We said that the non-vertex angles were congruent. The diagonals were perpendicular. The diagonal that connects the vertex angles bisects the other diagonal. And that vertex angles are bisected by that diagonal. Some great things there.